Hey everyone, how are we doing? We're here to start working on project number 2. Anyone in the chat? I think we're live. Maybe we are, maybe we're not. Mubot is here, I think. Mubot, are you awake? Mubot, are you? People can hear me typing. Hey Victoria, good to see you. Good to see you here, Dan. Let's start. We'll start talking about the project here. Brianna, good to see you. I'm going to start going over the project. Probably people will use this in the future. I want to point some things out though. Let's hop over here to the main screen. So let's do this. Oh, Mega Mondays. I'm gonna switch the intro here for now. Let me go over and there we go. I wonder if I could put that on my stream deck. We'll find out. Okay, so we have right here the instructions. These are all located under projects, projects 2, and you see right here the instruction file and you see the data file. So make sure to download the instructions and the data file under project, project 2. I'm gonna drop, I don't wanna go there. I'm gonna drop this if you can't find it. It is now linked in the video in the chat. So if you're watching the chat right now, you can see it and you can get that project file. So one big thing I also want to point out is throughout the project, where do I have it? I have it back right here. Good. At the very end of the project, you will see that there are help videos for everything. So there are help and tutorial videos for every single thing, like how to write your executive summary, taking a random sample, your confidence interval, histograms, box plots, single mean, all this stuff right here has videos for every single one of these. So if you're wanting to go over it, make sure to use that. We have helpful symbols right here, like your null hypothesis, your alternative hypothesis. Here, let's highlight them. That'll be easier to see. We'll just mention what all of these are right now. Can I not draw on this? There we go. It's back. The null hypothesis, that is what we start out with. The alternative hypothesis is what we look for evidence of. This is going to be your alpha level, which is the point at which we reject the null. I hate that it keeps bringing my cursor back over there. Here is your, we're going to bring this right here. That is going to be your, let's do that again. That is going to be sigma right there. That is sigma, the true standard deviation. This is mu, the true mean. This is going to be the sample mean, less than, greater, less than or equal to, not equal to, all the good stuff. This is the sample proportion right here. This is going to be the standard deviation for the distribution of the sample proportion. This is the standard deviation for a confidence interval. This right here is going to be your standard error for a sampling distribution. And this is the standard error for the sample mean. And then we have a z-score and a t-score with the associated degrees of freedom. So we have all this great stuff. Nice job right there, Dan. All the notation, we should kind of know it, get practice with it, and be ready to go. So let's take a look at what the project has us doing right here. You are working as an intern at a large media outlet. Your supervisor wants you to write a series of articles about college students and different aspects they have or are experienced this fall semester given the new policies and procedures. You have been directed to analyze certain variables collected from the University of Tennessee, Knoxville and create a report to be used in the creation of the article. The survey questions and descriptions are on page 6. So we have a limited amount of survey questions. We asked, what is your gender? How many credit hours are you taking this semester? Voting, do you plan on voting in the November 2020 election? Have you been tested for COVID? Black Friday, how much in dollars do you plan to spend on Black Friday? Are you a member of Greek society on campus? And recycle, do you recycle? And it might have often, never, but it's got options on how often someone recycles. One big thing I want to point out now that we know the questions is we also have an example report. So when you start your report, I would literally take this and use this right here. I would go, this is what I would do right now. I would take this and put this right here and start going into, submitted by Brian Stevens, executive summary. This is where I'm going to write my executive summary. My outro down here, this is where I'm going to write my future research outro. I'm also going to delete this and kind of just, use this as a template right here. So hopefully everyone kind of sees that this is going to get you, we'll just put in, that's just random right there. We'll do the 5. So that way everyone knows it is random. And then we're going to take, and I guess we got to make sure it'd be, I think it's 70 plus the last 2 on this one. This one right here for your project, when you take a random sample, your random sample is 60 plus the last 2 of your UTIDs. 60. Nice job, Mallory, right there, doing the project already. 60 plus the last 2 of your UTIDs. So this would be 115. So this is what we would do right here to show our random sample. My student ID is this, therefore I took a random sample of this. Everyone's going to have this. Once again, please do not copy anybody, but a lot of these are going to look very similar on this. We're not going to catch anyone for plagiarism for having this sentence, but obviously as you go deeper into the project, you're not going to be writing the same things. So hopefully it's making sense that we give you a structure right here, and I want to make sure that we highlight something right here. Let's put a note on these 2 that they are very important. We'll do it in big caps letters here. So these parts are very important. People, unfortunately, don't take these parts of the project seriously enough and kind of skip over the executive summary and the future research. Let's talk about the future research and the executive summary here just briefly. What are your goals in the executive summary? What are some of your goals in the executive summary? So in the executive summary, what will you be doing? Your goals in the executive summary. And I've got videos on this, so hopefully you'll kind of remember from doing the first project. In the executive summary, your first goal is to basically orient someone to the report. So your first goal is to kind of get someone on track and be like, here's what I'm doing research on. I don't want to give you answers to this. I don't want people to write everything I'm writing, but you want to orient it to be like, hey, here's what we're looking at. Here's what we're studying. Here's the group of people we're doing the research on. Then your second goal, which I think is the hardest part, is to summarize all key findings. When you think about an executive summary, you're basically looking at, when you have research papers, they give you everything there in the abstract. The abstract is meant to be like almost, you can get the majority of the report and the meat of it. So when you look at your executive summary, it's almost like someone should be able to read this and then not read your report. Why do you think an executive summary might exist? Why do you think if the executive summary exists, that someone can read it and then not read your report, why do you think it exists? Why do you think an executive might ask for that? Like, can you give me the executive summary of this? Why do you think they might want that? So think in the business world, why something might have an executive summary. And then it might help you better understand why it exists and what the goal of it is. So why would we have an executive summary? So if you're in a business and there's a bunch of reports and everything's going like flying, so they don't have to read a bunch of reports that are like, yeah, exactly. Victoria, you're exactly right. Even though it's only 5 pages, it's like, and then if they find it really meaningful, they'll go deeper in and look at all your numbers and your findings and your justifications. So really, the executive summary is like the whole meat of your report in a condensed format. And then your 5-page report is your whole like findings and graphs and figures that justify everything. So they can be like, oh, okay, they found this. So let me look into the details, the nitty gritty of it. And so Victoria, you're exactly right there. An executive summary is kind of the quick version of your report. So you need to lay out what your report is about. 2, give all your key findings and don't just like try to condense them, try to tell them in a way that, is quicker, but still gives the details that are important. That's the hard task. And then 3, You need to give your suggestions, whatever you're going to give suggestions on, or your changes, or your action items. Your action items need to be here. 1, orient the reader to what the report is about. 2, give all key findings. 3, give your action items, whatever they're meant to do, whatever the big suggestion is, make sure they know that. When you get down here to the future research, do not, and I've made sure we kind of made this clear, do not just go through all your findings again. Because if you were to go through your findings in your executive summary, and then go through all your findings here, and then just reiterate your findings, you've just gone through your findings 3 times. The point of the end, right? The point of the end is kind of a where do we go from here? This is, I like comparing it to a Marvel movie. When you think about a Marvel movie, it's kind of a teaser. You're downloading the jump on again here. Oh no, email me, Destiny. We'll get it figured out. Is anyone else hitting that error? Hopefully no one else is hitting that error. Email me, we'll get it figured out. And hopefully, was anyone else able to download it? Let's get some yeses or nos in the chat. In the future research right here, you want to go into new ideas. Maybe, here's some ideas for you. Kind of, yes, awesome. Maybe what could we ask UT students? Like what could we ask them in the future? Or what decisions should we, be looking into from this? As in like, what can we change? Or like, what can we do that we haven't even really thought of yet? So this is new ideas that go beyond the project. Then ideas on how to improve for the future. Yeah, and it's kind of the suggestions, but it's almost like the beyond. Think about this, like if we are studying students, because I don't want to give ideas, I don't want to say, because I've done it before and then I see it in all the reports. So I'm like trying to be as not specific as possible. Like, imagine, let's take Regal. Sorry, Regal, I love you, Regal. I mean, it's a crazy world we live in. Maybe Regal is trying to figure out a way to bring customers into the theater and to keep everything safe. Yay, we're hearing good stuff about the vaccine trials. So, hey. Oh, yeah, the Back to the Future example. You saw, yes, from the movie. And so Regal is going to maybe collect data on their customers and ask them, how their movie-going experience was. And so they might ask them, did you enjoy the movie with our new setup? And give them all these questions. So then they're going to have an action item from that. That all will be in the executive summary. But then if there was questions they should have asked, like if someone looks at the report and says, maybe we should ask people, due to our new limited menu, are you still happy with the food we're offering? What could we offer? And someone might say that would go into the future research. So an idea we did not talk about, like, we didn't analyze our food preferences, that would go into future research. Does everyone see the difference here between if we're talking to our customers about what they think about our current movies at Regal with the current world situation and how they feel about them, we're going to analyze that data, come to an action item decision, but then someone might say, well, we should have asked them about, the food options. The food options is going to go down here into future research because we don't have that data yet. We can't make action items. So don't do this. Don't say, we should analyze the food we're offering and offer more nacho options because people seem to really like nachos. Well, if you don't have the data to back that, don't make any suggestions about the food offerings yet. We'll find out, we can analyze that in the future. So the action item will go in the executive summary, whatever we're telling people to do, because when the executives get this, and if they're going to, make decisions from this, who's ever reading this, if they need to make decisions, that needs to go in the executive summary. Maybe we'll kind of drop some hints today about if something maybe should go in the executive summary. But does everyone understand the purpose of an executive summary right now? It is basically your whole report and the decisions that are going to come out of your report. So it is your whole report and the decisions that come out of your report. The future research will be things you will analyze in the future. You can't analyze them yet, but there'll be things you'll analyze in the future. Awesome. Great stuff right there. And I think that basically covers the first page. Please remember taking screenshots. Use snipping tool or Command-Shift-4, but really good stuff on the executive summary. So the first thing we're going to do right here is we're going to take a random sample. I'm going to show you the data that you'll be using, not that data. Your data, I just downloaded it earlier. So let me go get your data right here. This is not your data. And where'd I put it? So what happens when you have 20,000 tabs open? Like, where is that data? Here is the data that you will be using. This is your data. So if you see right here with the data on the screen, I'm going to make the columns a little bit bigger right here so we can actually read them. Got gender, credit hours, voting, COVID tested, Black Friday shopping, Greek life, and recycling. So we have all the variables right here. I'm going to kind of work with this data, but not do the exact same questions. Please note, Brian is not doing your exact questions for each one. So don't copy everything I do, because I'm not going to do the project literally. I'm going to go through each question and talk about it. So when we do this right here, this is a sample from UT students, and you're going to take a smaller sample out of this. So the ID number here is a what type of variable? What type of variable is ID? Going back to the very beginning. ID is a what kind of variable? Because we always look at our data to try to understand it first. ID is a what type of variable? It's an identifier. Nice job, Brianna, right there. It's an identifier. We have categorical right here. You can see categorical, quantitative, categorical, quantitative, categorical, categorical. So you can get a quick notion of what's going on. You can also, if you have jump 15, view the distribution of the data. A little more female than male. Credit hours are kind of centered around maybe 15 or so. We see a nice, good to see you here, Jane, right there, or Jamie. Good to see you, Jamie. And COVID testing, a little more no than yes. Black Friday shopping, people plan to spend around $80 maybe. Oh, there's an X in here? What? Let's analyze that distribution real quick. Is there someone put X? Oh, misentered data. And we've got here how often people recycle right here. So let's go ahead and take a look at the questions. The first one right here is to take a random sample. And you know what? There's no real way for me to not take a random sample from this. So let's go here to analyze, distribute, or go to table, subset. And this is how we take a random sample right here, table subset. And then we go to random sample size. We enter in the sample size we want, and we hit enter, enter. And you can just hit OK, but make sure you just select that to show you once again in the more classic format, table, subset. Then we go here to random sample size, click how much we want, and then we click OK. So this gives us our random subset. Please make sure at all points you're using this random subset. Please make sure. That is key to not messing up your project. I would even save this. I'd go to File, Save As, and call it like My Random Sample, just to make sure you're using 115 at all points. So let's hop back here to the project. Do not take a screenshot. You only need to report your sample size, and we've already done that right here. So we've already reported our sample size right here. Therefore, I took a random sample of 115. We are good for section number 1. Hey, I like it. Knocking out parts. How many sentences does section 1 need to be? I think that's it. If you look at the example project, because there's not much else to say, you look at the example, my student ID is this, and that's where my random sample size is. That's it. So we're done with question 1. There's not that many questions. We're on page 2. We got this. So historically, 40% of eligible voters in an election. Eligible voters vote in an election. I was like, what? Assume that UT students in Knoxville are eligible voters. Do you believe the true proportion of UT students voting in the election to be different than past elections? Take a moment and briefly explain whether you agree or disagree. There is no right answer here. Let's kind of talk about this. This one's just an opinion question, but you just need to justify your opinion. So let me ask this right here. Historically, we've seen that in the U.S., 70% of people own dogs. Historically, we've seen 70% of people in recent history own dogs. Do you think UT students, and we're talking about they own it personally, do you think UT students might be any different from that? Historically, 70% of people in the US own a dog in their house. Do you think college students might be different from that? Who has an opinion on that? And what would your opinion be? And how would you justify that? And Dan, so why do you think? So you think, yes, college students might be different. I made up the 70%. I made that up right there. So that's going to be kind of my fake question for this. So historically, 70% of people own a dog. It's a fake question. Yeah, it's a fake question. Hey, Calzone, what's up? Because it could be time consuming. Yeah, exactly. For college students, college students maybe are less likely because it's time consuming. And they might live in the dorms. If you live in the dorms, I've known people who've tried to own dogs in the dorm. The RA kind of finds out pretty quickly because there's usually barking. Dogs are not quiet. Um, Lots of student housing doesn't allow it. Exactly, Nikita. Great job, Nikita, right there. Yep, and that's the kind of reasoning that you'd be like, okay, I think they'd be less likely, it'd be different. We're asking, do you think it's the same? You're like, no, I think it's different. I think it'd actually be less. So it's the kind of reasoning we're looking for. And there's no right answer. Just give good reasoning. When we make grading keys for this one, this will say, like, if the student gives it good, reasonable thought, like, as long as they give a proper justification, give them all the points. So I would try to write 2-ish sentences right here. Does that make sense to everybody? I would try to write 2 strong sentences justifying why I'm saying yes or why I'm saying no. And I don't want to give you a yes or no either way on this one. I just want you to think of a good reason for yourself. And that's why we did a fake question right there. Okay, we have all 3 conditions you need to check for the data. Construct a confidence interval for the true proportion. Oh, come on. We know this. Condition 1, as soon as someone says it, I'm hitting the button. As soon as someone says it, it's happening. It's happening. Who knows condition number 1? Everyone knows condition number 1. What is condition number 1? Random right there. You got it. Condition number 1 is random. Nice job, Nikita and Victoria and Mallory right there. Condition number 1 is random. And I sadly know it was the first thing we did today. So we have here some conditions. And let me kind of make this easier to read with all the stuff we have today. We were kind of going over this during office hours. Swing by office hours anytime you want. We don't have many more left for the semester, but we're always glad to have you. So if you notice, this one I've kind of got a different color right here. That pen acts up sometimes. This one I've got a different color because it's for categorical. And what are we going to be asked to make? A confidence interval. That stands for confidence interval right there for the proportion. So success failure is going to be the third condition. Condition number 1 is random, which means we randomly select these. Is this a random sample? Probably, kind of. You could, because we've sampled UT students and then we took a random sample of it. Someone could say, or I think this data came from Stat1 students, but let's just say it's a random sample of UT students. So yeah, I wouldn't write the A and the B. I'd try to write like a report. Brianna, great question right there. I wouldn't write the A and the B. I would try to write it more like a report without the numbers. So really good question, because we're trying to turn this in like an actual report with like sections, like this section covers this and this section covers this. Excellent question, Brianna. Thank you so much. So don't include the numbers for the questions. And then we have 10%. What does 10% mean? We kind of give a hint at this. 10% means that our sample is what? 10% means that our sample is what of the population? 10% means that our sample that we have is going to be what of the population? The 10% condition means that our sample is less than 10%. Nice job, Mallory and Nikita right there. It's less than 10% of the population. And I'm not telling you the answer, but do you think your sample of mine was 115? Do you think your sample is less than 10% of this population? I'm not telling you the answer, but just Victoria maybe knows. Yeah, you can say that. Keep answering the chat. It's so good. If no one was here in this video, it'd be so boring. Definitely. We got some definitely's and yes in the chat. I'm going with the chat on this one. I'm going with the chat. And then the last condition is going to be success failure. Now, if we were doing Brian's dog question, which was 70%, let's say 70% of Brian's sample owns a dog. If 70% of Brian's sample owns a dog, what does this mean in words? If 70% of Brian's sample was hypothesized to own a dog, we would expect 80.5 people to own a dog. And we'd expect 30%, which is 34.5 to not own a dog. So we need at least 10 expecteds and at least 10 failures. Does everyone see the mathematics I'm showing right here? The mathematics that I am working are... We are doing that one. Yeah. No, let me change this. Sorry. Because we're doing a confidence interval. I just did the one for testing, and this is the one for a confidence interval. So please... I wish I could cut out that part of the video. My brain skipped a beat. But if we're doing the one for a confidence interval, we're actually going to have to look at the data and jump. Would you multiply the count by the probability in the frequency table? Well, what you can get right here, so actually, Mallory, you're basically on the right track, and it'll be easier than you think. Watch this. Let's go to our random sample right here, and let's look at voting. No, voting was the one we wanted, right? So let's do this one. Let me see Greek life. We got the X. I'm not going to do that one then. COVID testing. It has been said that, look, this is a fake question right here to kind of do the same thing. It has been said that 20% of the U.S. has been tested for COVID at this point. 20% of the U.S. has been tested for COVID. Do you think University of Tennessee students might be any different? It has been said that 20% of the U.S. has been tested for COVID. Do you think that college students might be any different at UT? What would you think? Do you think college students are more or less likely to be tested for COVID? So this is like the first part of the question again. I would say they'd probably be more likely because, college is kind of a more social area. So I would say maybe, good to see you here, Evan. I'd say they're maybe more likely. So maybe more likely. So let's go right here and let's do analyze distribution. And let's go to COVID test. And we see in our sample that 35%. And so I think, Mallory, here's what you do. This right here is actually NP hat, and I'll show you how that is NP hat. This number right here is NP hat because you could take and do P hat, which is the sample proportion times the sample size, and it's just a rounding thing. But this 41 right here is NP hat. Does that make sense, Mallory? So this is actually NP hat, and that's NQ hat right here. So this is NP hat, and this is NQ hat. And does this meet the success failure condition? What does the success failure condition say? It says we need at least 10 successes in our sample and at least 10 failures in our sample. And success and failure are just like yes class, no class, like at least 10 yeses, at least 10 no's. So I'll let, yep. And so that's NP hat and that's NQ hat. Sorry, I was thinking about the test for a moment because we were doing testing all today and I did the wrong equation. We are good on that one. Hopefully people are understanding. Use JUMP to analyze the voting, which will produce a bar chart and frequency table and add a 98.5% confidence interval. Include the screenshot in your output. So we did it. Let's review the steps to do this again. I'm doing a different question, but you can select the variable. So you can do this. Sometimes I'll do that to select it. Then you can go here and you can click, let's slow down, analyze distribution. Got to remember, can't go too quick because people might be watching this later. Analyze distribution. You can double click the variable or click the Y columns. You just want to get it right here. Click the OK button, then go to the top right arrow just to make it look nice, stack it. You know what? We're going to make it look extra nice. We're going to go to Histogram options and go to count access. Then we're going to take this and we're just going to expand that a little bit. Look at that. So much nicer. Don't worry if you don't do that, but you can always right click and you can go to things like color. So if we go to histogram color, we could choose a nicer yellow. I don't know about that. That's not my favorite color. This is going to be my favorite color right here. That's cool. If you get that the blocks are selected, go up here to the top and go to rows and go to clear row states. So that'll deselect those right there. That was up here at the top, and go to rows and go to clear row states. We'll remove any sort of selected areas on the graphic. And now we have we're not going to take the screenshot with that on it. Watch out, move this away, and you have your screenshot. One last thing that we are going to need is we are going to need a confidence interval. So you can choose any % confidence interval that you want. You don't have to change the color. I'm just having a little fun. Just to make it look nice here. You don't have to do any of that. It's just niceties. It's just fun. And so we're going to go here to other, and you can select whatever you want. I'm going to put in a 99.2, but put in the percentage on the project. So I'm doing this so people just don't copy what I do. So you're meant to go here and follow along with the project, but this is the % confidence right here, whatever you want it to be. So kind of saying, hint, like I was saying. But this is where we put in the % confidence, and then we get the associated % confidence interval right there. And we will take a screenshot. That's the normal curve. You can take it in 2 screenshots. Make sure to take some nice screenshots like this right here. And so 2 screenshots is probably what I would do. I just don't like really long output. And I would take the 2 screenshots right here and make sure they're just nicely isolated on the screen. So we now have our 2 screenshots, and we have our bar chart, because it's a bar chart, because this is categorical data. It's not a histogram, even though I think it even says histogram, but it's actually just a bar chart because it's categorical data. So let's continue on, and great work, everybody. Let's see, interpret your confidence interval in context of the problem for those planning to vote on the election. So whenever we do a confidence interval, and this is really good confidence interval review, we say, I am blank % confident that the true blank is contained in the interval blank to blank. Okay. So the mistake people usually make is on the second part over here. The first and the third part are the easy parts. Let's bring up that output right here and just take a look at it. I think we have just enough room. Oh, darn. We'll have to take away a few of these. Went way too long on that. This will do just fine. There we go. And let's put it on the screen here together with it. Cool. So the percent confidence is right here. This would be 99.2% confident. And then this is going to be the context of what we're talking about. And this is the interval right here from the lower to the upper. Does anyone have any idea how to interpret this interval? Can anyone do it in the chat right here? I want to see if you can do it, but try interpreting my interval that I am blank percent confident that the true blank is contained in the interval blank to blank. Remember, we went and took a sample of UT students and asked them, have they been tested for COVID? So I am 99.2% confident that the true proportion of UT students who have been tested for COVID is contained in the interval 24.95% to 48%. I am 99.2% confident that the true proportion of UT students who have been tested for COVID is contained in the interval 24.95% to 48.00%. So that's a 99.2% confidence interval. Please note that you don't always say true proportion. Sometimes you'll say true mean. It just depends on what you are testing. But this is how to interpret confidence intervals right here. Just make sure to know where to look in the output. Here's the lower bound, and here's the upper bound for the students who have tested. Include the formula for the confidence interval using the proper mathematical notation. You can also copy paste in the project. So I guess I kind of have to, well, no, I guess. So I think we want you to put in your numbers. So the formula for the interval, I'll write it in right here, but I'd also solve it. So I'm going to let you solve this. So I'm not going to solve this, but let's go right here and just write it. There's a lot of help right here. It's like, there's really no way for me to do this one without. So the formula is, it has a center. I'll erase this afterwards. Every confidence interval has a center plus or minus a margin of error. Every single confidence interval has a center plus or minus a margin of error. And the margin of error is going to be the z. And then we do square root of p hat, q hat over n. And so when you look at this right here, what does the z do for the confidence interval? What does the z do? The z controls the what of the confidence interval. It's part of the margin of error. But what does the z do? It's part of the margin of error. It's part of this right here. The z is part of the margin of error because the margin of error is just everything after the plus or minus. But what does the z do? What does the z do? The z, it'll control the percent confidence. The z will control how percent confident we are, because if we use 1, it'd be 68, 2 would be 95, or 1.96 technically, 68, 95, 99.7. The bigger the z, the more confident the interval is. The bigger the z, the more confident the interval is. So if you were to go from a 95 to a 99, the z would increase. If you go from a 95 to a 90, the z decreases. And so the z is directly linked to your confidence level. There are other things that control your margin of error, like the sample size, but the confidence level right here is controlled by the z-score. So let's put something right here for everybody and say, add your numbers. So add your numbers. Because I can't do everything. But add your numbers in. So go ahead and add your numbers. I would show the equation, and then I would add your numbers in. So I think that's good right there. State your conclusion regarding the initial hypothesis. You know what's really crazy? Does anyone remember what I said for, oh no, I think I said 20%, didn't I? What percent of people did I say have been tested for COVID in the general population? What percent of people did I say have been tested for COVID in the general population? Was it 20% or 25? Can't remember. Was it 20%? I think it was 28%, right? So think about this. I am 99.2% confident that the true proportion of UT students who have been tested for COVID is contained in the interval 24.95 to 48. What do you notice is not in this interval? What do you notice is not in this interval? We'll take the whole thing right here. What do you notice is not in this interval? What explicitly is not in this interval? What do you notice is not in the interval? Yeah. So think about this. You're saying you're 99.2% confident that the true proportion of UT students who have been tested for COVID is contained in the interval 24.95 to 48%. So what would you do to that, Victoria? Would you reject that value or not reject that value? If you think about it as a statistical test, which we almost did today, would you reject 20% or not reject 20%? If you think about it as like a test. And this will be a concept we'll be doing next class, which I think you might get right here. So this is a review of rejected, exactly. Anything that's outside the interval can be rejected. So let me change this. We don't want a white pen, we want a red pen. So anything that is outside the interval, oh my gosh. Oh yeah. Anything that is outside the interval can be rejected. So if it's outside the interval, we reject it. And if it's inside the interval, we do not reject it. So if it were to be inside the interval, then sometimes we'll say retain the null. I will put fail to reject. Fail to reject. Classic, since everyone will be watching this. So if it's outside the interval, you can reject it. If it's inside the interval, you do not reject it, which means fail to reject. So do you think it's possible that 30% of UT students have been tested for COVID? Do you think that that's possible, that 30% of UT students have been tested for COVID? Do you think that's maybe 30% of all of UT has been tested for COVID? Yeah, and why would we think that that's possible? Why would you still believe that? Why would you still believe that? Why would you say, yeah, 30% seems reasonable to me? What if I said 40%? Yeah, 40% seems reasonable. What about 45? Yeah, 45% seems reasonable. It's within the interval. So anything in the interval we do not reject. Now, here's the thing why we don't say accept. You don't say accept. You wouldn't say, I accept that 30% has been tested, because you would also have to accept that 40% has been tested. You'd also have to accept that 45% has been tested. That's why we say, I don't reject that, or I fail to reject that. You're just saying, I don't have evidence to go against that. Right now, that seems reasonable to me. So I'd believe that if someone said it, like, that seems reasonable. I can't reject it. So I'm willing to say that, yeah, sure, that goes along with the data. Like, the data is in line with that. These values that are outside the interval are values we would reject because the data does not support it. It's unlikely that we would see this given that that's true. So we would reject those values outside the interval. Does that make a little bit sense here? Because basically a hypothesis test can be done with a confidence interval. If something's in the confidence interval, you fail to reject it. If something's outside the confidence interval, you reject it. So this is the connection we will see at the very start of next class, that confidence intervals and tests are basically the same thing. So hopefully this is a really good right here review for anyone who's done this so far. Something's in the interval, you fail to reject it. Something's outside the interval, you can reject that value if you're doing it with a hypothesis test. So that has question number 2 done. Excited right here. Let's hop here to question number 3. Generate and include a histogram of Black Friday shopping. So I'm going to have to do a different part. How would you find the z-score in part E? Did I miss a z-score? Include the formula interval. Oh, yeah. Oh, yeah. Okay, yeah, sorry. Your z-score is going to be based on this. Let me drop this in the chat. Thank you, Mallory. Great job, Mallory. 1,000 points, Mallory. You didn't expect to get points today, but thank you. I appreciate it. To find your z-score, you need to go over here and go to the between. We were talking about this a little bit in class today. Should be about so many problems. I think I skipped it. Here we go. So the between is how we use confidence intervals right here. So if you're doing a greater than test, it's above. A less than test, it's below. And the does not equals test is the outside one. So there's where you use your testing based on the sign. But this one right here is for confidence intervals. And you need to click this button. And my z-score for my interval would be this. This is my z-score for my interval. And you can see here 68 is very close to 1. 95 is very close to 2. And 99.7 is very close to 3. It's just that there's extra decimals we don't see. We just say 68, 95, 99.7. So 68 is 68.23, I believe. Ooh, there we go. It's actually that. 95.449. So that does round up. And those, does the evaluation of a hypothesis null not rely on the p-value? It does. But Sam, great question right there. So what we're doing is we're actually doing kind of like a trick, because we can use the interval. We can use the interval right here to reject or fail to reject the null. Now you could go, and Jump does it a little bit differently for this. It doesn't use a z-score. You could go right here and go to test a probability. And don't do this, though. Don't do this. Don't do this. This is not part of the project. But I could test 20% right here, and I should reject that because we're going to use the not equal to. And you see we are rejecting it. And Jump is using the chi-squared, so do not do this. But do you notice how we're going to reject this probability with a very small p-value? And is that in line with our interval right here? You can use the interval to see if you reject the value. And any value that is outside your interval can be rejected. We've drawn it right here where 0.20 would be outside my interval. And so we're not using the p-value, we're using a confidence interval, which is basically the same way. And it's in the notes right here. If you're looking for the notes on this section, here it is right here where we're testing values to see if we can reject them based on if it's in the interval. And then we can use a confidence interval to reject that value if it's not in there. Confidence intervals and tests are connected in that way that you can look at a confidence interval, and if the value is inside of there, you do not reject. And if the value is outside of there, you do reject. So the notes go over there. You can approximate a hypothesis test using a confidence interval. So Sam, you are correct. You would think with a hypothesis test, you'd use a p-value, but the confidence interval can estimate and do the same procedure for you. Does that make more sense? Maybe I did the wrong thing. I solved for the standard deviation in the z-score, found the p-value from there. Yes. So this one right here, include the interval for the, or include the formula for the confidence interval. Yep. And so this right here, use the interval for the confidence interval, include the formula for the confidence interval. Does that make sense, Sam? So good catch right there. A project help to the rescue right here. And then I've kind of got where we're adding in your own numbers, and we drop the David M link in the chat. And please, I could make a mistake. It's possible. And then I'll be like, hey, Terry, I made a mistake on the help video. Please tell me if you see anything that I make a mistake on. Generate and include a screenshot of a histogram for a quantitative variable. This is the one you'll be using. Interpret your graphic. Make sure to talk about the shape, center, spread, the distribution. Comment on any unusual features or outliers you see. If you do not see any unusual features, you do not need to remove any data points. Only comment on them. Okay, cool. So let's go ahead and go to our data. We will not be using Black Friday. We'll be using credit hours. So we will be not using Black Friday. We'll be using credit hours. Please use Black Friday for your question. Once again, I am doing different questions because I don't want you to just copy what I'm doing. I'm going to go here and use credit hours. So let's go here and go analyze distribution. Slow it down again. Analyze distribution. And we are going to make the histogram right here by going to credit hours and clicking OK. And then click the top right arrow. And what do we have right here? What's the deal with this distribution? What's going on with this distribution right here? It's very, very what? I see this, and I see there's this, and then there's this. And this is a very odd distribution. It is a right skew distribution, definitely right skewed because it's got more to the right. It's kind of got the tail right here, but it's also got a buildup on the left side, like a lower limit of 12. It's kind of got this buildup around 12. You see there's even the lower 10%. So you've got, and you can even see how many, there's 12 students right there. And if you're wondering how I did that, I was holding control. And so I unclicked it. Another trick right there. But there's 12 students. I think you can hover over it too and it'll tell you. Nope. Oh, there it is. Yeah. 12 students right there. And it's 12 and 13 included. So it does, there's a student with 13 right there also, it seems. Oh, no, it's the bin widths. Tell me the bin width. And so right here, we see a very right skew histogram with some high outliers of students taking, and I'll hover over that. You can tell me 20 hours and a student taking 21, I guess. Yeah, you go right down. So we've got students taking 20 and 21 hours and a very, very right skew distribution. The center of this is going to be described by the what? What would be the center described by? The center is best described by the what? The center is best described by the what, because this is right skew. Since this is right skew, the center is going to be best described by the what? Since this is right skew, the center will be best described by the what? If it's skewed, we need to use the median. If it's normal or mostly unimodal symmetric, we'll use the mean. So since this is so right skewed, we'll use the median. Yep, median. Nice job, Destiny, right there. And so the median goes with the IQR. The IQR is 2 because 16 and 14 have a difference of 2. So the best way to describe the center right here would be the median, which is the 50th percentile of students' credit hours is 15 hours, and the middle 50% of students have a range of 2 going from 14 to 16 hours. So the IQR is the best description of the spread of students' hours because of the skew. So you notice the shape is right skew with high outliers at 20 and 21 with a little bit of low buildup there at 12 hours. The center is best described by the median, where students have the 50th percentile of students taking 15 credit hours, and the spread is best described by the IQR, where the middle 50% of students have a range of 2 in their credit hours going from 14 to 16. What is the next question? Clearly state all 3 conditions. You know we got to do it. Someone tell me, what is condition 1? We're going to perform a hypothesis test on the mean. What is condition 1? You know it. Everyone knows condition 1. Condition 1 is going to be random. You bet. Condition 1 is random, and condition 2 is 10%. So condition 1 is random, condition 2 is 10%, but now we're no longer doing success failure. We're doing a confidence interval for the mean. So we're going to be doing this one right here. So we're doing a confidence interval for the mean. So now we need to know if it's nearly normal. And there's a lot of ways to check this. Let me see if the project suggests something. Explain how these conditions are met. Show proper numeric justification. So let's go ahead and see. Since my distribution is right skew, my sample size should be at least what? And it's not heavily, I wouldn't even say it's heavily skewed. Since my distribution is a little skewed or kind of skewed, it's not, I've seen things way worse. 25. Yep. And so if it's right skew, it needs to be 25. If it's heavily skewed, it needs to be 100, or skewed 25 and heavily skewed 100. I like to use those constants. When solving for the z-score, is it basically, yeah. And which one are you working on? Is that for D? Yeah, we'll be there in 1 second, Sam. We got this. Basically, and you'll be solving for a T on this one. So if you're talking about D, we'll be solving for the t-score on this one, because this is the this is a mean. So Mr. T is mean. I'm sure he's a super nice guy. It's just the way I remember Mr. T is mean if you're doing drugs. So he's nice to everyone else, but he doesn't want you doing that. He wants the best for you. So be good to Mr. T and be good to yourself. So let's go right here and let's see. We do meet all the conditions. Use JUMP to produce a 93% confidence interval. So one of the great things about JUMP is how standardized the things are. If you want to produce a confidence interval, you go to the second red arrow. How skewed would it have to be in order to be heavily skewed? I'll draw pictures real quick. So we'll pause on this one for a second. I'll draw some pictures. Generally, when you think of these conditions right here, if it looks pretty normal, then 1 is good enough. And this is kind of skewed. And then I think of this as heavily skewed. Now, here's the big thing. When you get to upper level statistics, we have way more advanced ways of talking about this than this. So if you're wondering, well, like, that's kind of like, well, when does it look exactly like these? We have more advanced ways, and we have statistical tests to figure out. So we have goodness of fit tests that we use more often. But then with larger sample sizes, the central limit theorem kicks in, and the distribution of the means of these are usually more normal because of the central limit theorem. So the distribution of the means of these will be normal. And that's what the central limit theorem says, that these distributions will be tighter and more normal based on a larger sample size, because we're not doing a confidence interval for a single observation. We're doing the confidence interval for the mean. Does that make sense, Victoria? The central limit theorem kicks in, and these distributions become tighter and more normal. And that goes all back to the central limit theorem. And so how would it have to look? That's a really good question. And then we can go into more like theory. Great question, Victoria. I love answering those. I love theory questions. It's so crazy. I always hated musical theory, and now I love mathematical theory. So we've made our conf interval. We didn't make it yet, I don't think. Let's make the conf interval. So we need to go here and go to the red arrow, go to confidence interval. We need to go to other to get the percentage we want. We can put in whatever percent. We just need to follow the instructions. Follow the instructions. I'm going to put in a 80% confidence interval because I'm not following the instructions. Make sure you're following the instructions. Some people listen to these on mute, I swear. Sample size of less than 100, so I want to make sure that I pass the conditions. Oh yeah. If I would say, let me look at how that data looks. Here, I'll copy this interval because we've already made it, and then let me look at how the data looks. Do not include the questions in your write-up. Do not include the questions. I am just kind of, it's meant to look like a report. I'm just doing this to make sure I follow it. It should look like a nice report. I'm just kind of going through and helping out here. Don't include them. Let me see how your data looks. It shouldn't be too skewed. I'm seeing just kind of, I can see an overview of what mine looks like up here, and that's moderate. And if your sample size is less than 100, I mean, I don't think this is too heavily skewed. Even mine, it's moderate. 100's really for more like extreme skew. So I'd say you're good. Like 100's for more like the upper end of skew. So if you look at my drawings right here, or unless I deleted them already, no. 100's more for the extreme skew when it's really just like built up on one side and extremely skewed. It could be left skewed also. It's just the more skewed it is, the larger n needs to be. And so that's the large enough n. Brother's texting me here. So does that make sense, Victoria, right there? An excellent work. Hopefully people complete the project. Oh, gosh, that'd be awesome. So how do we interpret this interval? I want everyone to tell me, what am I going to say after when I get to right here? I am blank % confident that the true blank is contained in the interval blank to blank. Remember what I was trying to do? I was trying to find the true mean what? I am blank % confident. So I am 80% confident that the true what? And what was I trying to find? The true proportion of credit hours? The true difference in credit hours? The true what? I am 80% confident that the true what? So I am 80% confident. The true mean exactly. Nice job, Sam and Victoria right there. Sam, let's make you a mod on the channel. Sam, welcome to the mod crew right here. So I am 80% confident that the true mean credit hours for UT students is contained in the interval 14.98 to 15.41, which, what if someone told you, I think UT students take 18 hours on average? You'd be like, yeah, my interval doesn't suggest that. My interval, no. 18 hours seems way out of range. I reject that value. 18 seems way out of range. So 18 would be a value with this interval we would reject right there. I reject that value. And what I'm going to do is I'm going to change this because I want to show you something. The % confidence you use is related to the alpha level you have. So an 80% confidence interval would be testing with what alpha level? 80% confidence would be testing with what alpha level? 80% confidence would be testing with what alpha level? 80% confidence would have what alpha level test? Because 1 minus alpha equals this. So what's your alpha level if you use 80% confidence? It'd be what? Because 1 minus alpha equals 80%. So what's alpha equal to? It's like 1 minus x equals 0.80. So x would equal to 0.20. What do you think is the most common confidence interval to make? Nice job, Victoria, right there. What do you think is the most common confidence interval to make? The most common confidence interval to make that people make most often is a what % confidence interval? The most common interval that people make when they make confidence interval is a what % confidence? It's 95. Why do people usually make 95% confidence intervals? Nice job, Mallory, right there. Why do they usually make 95% confidence intervals? Why do they usually make 95% confidence intervals? Why would 95% confidence intervals be made? Why would you make a 95% confidence interval? Because a 95% confidence interval would directly relate to what kind of test? If you have 95% on the inside, it directly relates to this right here. And this is our next lecture. Alpha is 0.05 exactly. It's a does not equals test. So 95% confidence interval relates directly to the 0.05 does not equals test. So does this make sense right here? So the alpha is right here. So here's your alpha, and here's your confidence interval. So 95% confidence interval is directly related to a two-tailed test with 0.05 alpha. And you can do any sort of alpha level or any sort of confidence interval, but classically people use a 95% confidence interval. So we're trying to hopefully teach a few things. So if you're watching this is really good stuff for the test right here. But just hopefully that visual makes sense right there. Okay, so we interpreted our interval, include the formula for the confidence interval. You can copy paste the symbols. So bonus to you for watching this, because we're going to go right here. We're just going to write it. Now this is going to be the hard part. Once we get everything, y bar plus or minus t star with n minus 1 degrees of freedom and s over square root of n. So this is the hard part for people, is usually the t statistic. So the t statistic is usually where the error is at. The n minus 1 is the degrees of freedom, but to find your t statistic, I think we still have no, we don't have our t applet up right now. Let's go grab a t applet. So my favorite is stat distributions t, and let's go pull it up right quick. So here is stat distributions t. I'm gonna drop it in the chat right now. So would you say I failed to reject the null because it falls within the confidence interval of the true mean? Yeah, you might be on another part. Make sure, yeah, Sam, that sounds about right. If something falls in the confidence interval, you would fail to reject that value. So Sam, you're on the right track right there. I fail to reject this value because it's contained within my confidence interval. Yep, and then you could say at what associated alpha level. So if you use an 80% confidence interval, you would fail to reject it. Oh, no. And tell me which number you're working on, Sam. We can go back to it. Hit the live button down below. There should be a watch live button also. And you can always tell me what number. Don't worry, Sam. Keep throwing those questions. You're here to learn. We're all here to learn. Don't worry. It's people watching this later. They don't get to ask questions. They can put them in the comments, but but they can't ask them live. Our sample size was 115. So our degrees of freedom would be what? Sample size 115, degrees of freedom 114. Notice how the shape of the distribution changes the more degrees of freedom you give it. It gets tighter and more normal with the more degrees of freedom, and you basically have the normal. If we're using a 95% confidence interval, it's going to be basically 2 again, and there's the 95% confidence interval t statistic. Depending on what you're using, like when I used an 80% confidence interval, this would be the t statistic right here for an 80% confidence interval. So this would be my t statistic for an 80% confidence interval with 114 degrees of freedom. The degrees of freedom are obtained by doing 1 minus the sample size. 1 minus the sample size is the degrees of freedom. It doesn't say it in this output here, but there's my sample size. 1 minus that will be the degrees of freedom, and then you use that to find the t. My t for this interval right here, the 80% confidence interval, is this number right here, because I have 80% shaded and I have 114 degrees of freedom, and this is the t statistic. The t is different from the z, but it's very much like it. The t and the z are very, 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 very similar, and that changed what the output was. Your supervisor thinks the true mean of this will spend $100, conduct a hypothesis test. You decide the alternative to use. Oh, cool. You decide which of the alternatives hypothesis to use. Clearly state the null in the alternative and provide a full conclusion of the hypothesis test in context of the problem supported with the information. So T is for mean when you're not, yes. So technically, and Sam here, I'll give a real brief, talk about that real quickly. So this is a very, hopefully I'll make sense of this all. So if anyone's wondering, 1 proportion Z test. 1 sample mean Z test. 1 sample mean t-test. Okay, so we have 3 tests right here, and one of them we will not use in this class. So the z-test is p hat minus p naught over p naught q naught over n square root equals z. The t-test or the z-test for the mean is y bar minus mu naught over sigma over square root of n. This one down here is y bar minus, and that equals to a z-score. And then this one right here is y bar minus mu naught over s over square root of n. and that is equal to a t with n minus 1 degrees of freedom. So if anyone's wondering, especially if you took another class, you might have done a z-test when testing the mean. This is when you know the true standard deviation, you would use a z-test. So you just say sigma z s and t, sigma z s and t, because I've taught this before. So sigma z s and t. So s goes with t and sigma goes with z. The theory behind this is that when you don't know the true standard deviation, you have to use the sample standard deviation. And this is where William Gossett, we'll put his name down here. William Gossett worked at Guinness Beer, and he made the t distribution. So William Gossett made the student t distribution to do this correction. And so, especially when I think about this, I've talked to my dad about it, a lot of times you really don't know the true standard deviation. So in our class especially, we don't even teach the z distribution. We just teach, or for the one sample test on the mean, we just do the t. So we only use s and t. So we don't teach that that test right there. Does that make sense a little bit more, Sam? That's a little bit in depth, but this is the formula right here. And if you remember s and t, when you're using s, it goes with t. That's a good way to remember it. The sigma z part we won't use because we're not going to use the one sample mean test for z, one sample mean z test. So hopefully that makes a little more sense. This is the guy who worked at Guinness Beer, and he added in the extra variation due to the sample size. And that is the correction due to the degrees of freedom, which equate to the t. This is chapter 14, I think. I could pull up those notes really briefly right here. Chapter 14, I think. So let me go to chapter 14. Yes, it's chapter 14. I'll show you real quick right here. So it's a good review of notes. This is I want the video to be this, that people can maybe review some of the topics and, go through. So we should see William Gossett here in a second. Where are you at, William Gossett? Where are you at? There he is. There's William Gossett. Nope, there he is. So here's William Gossett. Here is his t distribution that he created. And yep, so it's right here where William Gossett made the t distribution. And it's basically the normal, but it has with it degrees of freedom, and we'll be using it for the mean. This is the first time we started talking about the nearly normal condition right here. So hopefully this is a good review. Remember, we don't use, here's the sigma right here, and that would be with the z, but we switch it to s, and so we're going to use the t distribution right here, William Gossett's t distribution. And so remember, s and t go together. So that's a kind of a good way. Remember s and t, so this value right here is going to be a t with n minus 1 degrees of freedom when you end up solving it. So hopefully, really good questions right there, and hopefully that helps out with kind of understanding kind of the theory behind this a little bit more and getting ready for the test. So that's what we're trying to do. Look at all those Word documents. So with this one, we need to perform a hypothesis test, and we're going to do it in JUMP. JUMP makes everything so much easier. To perform a hypothesis test on the mean inside of JUMP, we go right here. I'm going to remove this output for the moment right here. Remove. And we just go right here and we go to the red arrow and we go to test mean. I'm going to test 15.6. I'm going to do the does not equals test. Who thinks I will reject 15.6 with my does not equals test, or who thinks I will not reject it? Will I reject 15.6 or not reject 15.6? With the does not equals test, will I reject it or not reject it? What do you think? And look at my interval. Will I reject 15.6 or not reject 15.6? Using a 0.05 alpha. If you see, we've got a 95% confidence right here, and I put 15.6 for a reason. We will reject 15.6 because it's outside my interval. And this is because anything outside this interval right here can be rejected with 0.05 alpha. And I thought a hood right there. We'll reject it because it's outside the interval, and anything outside the interval we can reject at the 0.05 alpha level. So you notice here's my two-tailed test. You can also do the following. Since I chose a two-tailed test, I can go to p-value animation and actually show the two-tailed p-value test. You can do the less than test, the greater than test, or the does not equals to test. So this right here tells me that with a p-value of 0.01774, we reject the null hypothesis. Does it want me to write the null alternative? So conduct a hypothesis test, you decide which alternative to use, clearly state the null alternative. Let's do that. So with the null and alternative, we're going to do some notation right here. So let's put this here. We're going to go H subscript O. The subscript buttons are up here. And let's go ahead and insert And I'm going to let you pick, not equation, between one of these. Pick one of those. The null always has the what sign? 0.05 alpha being 95% or more confident. Explaining greater detail, Sam. Explaining. So 0.05 alpha is because it's a 95% confidence interval. So 0.05 alpha is the whatever you do for your confidence, like 80% is using a 0.20 alpha, 90% is using a 0.10 alpha, 95 is using a 0.05 alpha. So it's the related alpha level you're kind of testing at when you use a confidence interval. Does that make sense? So if you use a 90% confidence interval, it's related to a 0.10 alpha level for a two-tailed test. It's where you'd be rejecting it if it's inside or outside that interval. It's, please ask more questions if you want to know. We'll definitely say. The null has the equal sign, and then hypothesized value. And here's some good basics. Here's some big hints. This is not the answer. It's right over here. Let's write not the answer. It's a few times on this project I've not given the answer. So let's put out here a thing like not the answer. Not the answer yet. Don't copy that down as the answer. Oh, wait, yeah, and it'd be in the alternative. I need to change this here. It's got to be one of these. And this is not the answer yet either. And then we need a not equal to. But one of these right here. One of these right here. And you'll pick this one. So would it be not... Yeah, I think it says you can pick it, right? You decide on the alternative to use. So you can decide on the alternative to use. So you can pick one of those because we either do less than, greater than, or not equal to. When do we use P? When the data we're dealing with is what? When would we use P? So we'd use P when the data we're dealing with is what kind of variable type? What kind of variable type would we use P for? What kind of variable type would we use P for? Categorical, nice out, Victoria, right there, yep. And then this is quantitative because it's dealing with mean. It's the true mean, and this is the true proportion. Yep, and then we do have mu1 minus mu2. I didn't put that in here as an option, but maybe I should just put it for notes purposes. But there's also, you can do P, mu, or mu1 minus mu2. So this is comparing two means, the difference between two means. This is just looking at one mean, and this is looking at one proportion. So hopefully just kind of a review right there of what we can put in, what we can test. This is not the answer right here, but I hope that... Is that it? What? Man. An hour. So if the null lies within the confidence interval, we can reject it. Well, for this one, we're going to actually do the test via the test. Well, here's the big thing. Let me say it. When you look at the confidence interval to reject it, what alternative is related to doing confidence intervals? When you look at confidence intervals, it's related to doing a what sort of test? When you look at confidence intervals, it's related to using the what alternative? When you look at confidence intervals, it's related to the which alternative? So I've got it here on the screen because I've got the confidence interval on the left, and then I've got the alternative on the right, and a confidence interval is related to a what-tailed test because it's the same as doing this sort of test right here, a two-tailed test. So watch this. Let's take a value. I want you to give me a value that we would just barely not reject on the two-tailed test. Tell me a value that we would barely not reject. So give me a value, Sam, that we would just barely not reject at the 0.05 level. On the two-tailed test, I want a value that we would just barely not reject. So what's something we would barely not reject? And I'll go here and I'll test it. So I'll go to test. Be careful. Be careful. We would reject 15.4. We would reject 15.4. Because, oh no, you're right. You're right. What am I thinking? My gosh. I was going even closer. Wait. Yeah, you guys are right. You guys are right. No, you're right. I get one mistake, and that's the one mistake. I'm going to do this. 15.28. Okay. This number is where? This number is where? Sorry, I skipped a decimal, and I was looking at the 2 because I was looking more decimals out. This number is in the interval or out of the interval? It's in the interval or out of the interval? It's just barely where? Barely in the interval. So I'm going to guess that the p-value on the two-tailed test is going to be 0.0501, 0.0501, 0.0509. On the two-tailed test, which is the absolute value one, it's 0.0509. But what if I were to do a test where it was just barely outside of the interval? So now if I do a test where we go just barely outside and do 15.530, I'm going to say it's going to be 0.049. And now it is right there, 0.049. Because this one is just barely outside the interval. This one's just barely inside the interval. And it would work the same way if I went on the low side too. But do you see how these numbers right here are just either barely outside, you reject, barely inside, you don't reject. And if you were to copy this down all the way, I think it would be exactly 0.05. So we can show that last example right here. But if we go and just, let's copy the whole number and go here to test mean and go to 15.529364, we should get 0.05, pretty close to. There we go, 0.05 on the dot. Because that number's on like the edge of it right there. It's saying it is statistically significant probably because it rounded it up. If it shows it, it's exactly 0.05. Yeah, because it's right on the interval. Is this making more sense that how a confidence interval does the same mechanical work as a two-tailed test? And what kind of alpha level is used is based on the percent confidence. How's everyone feel about this? And I think we've covered the whole entire project. So you'd want to think about like more questions, craft a closing paragraph that brings new ideas for future data research. You know, where could you go from here? Leverage your education, tie into future analysis and concepts. Would you mind explaining the three values there? The three values I used to test. These three values right here. So this one is one just explain a little more, Sam. This one right here is a value just barely inside, and we just barely don't reject. This value right here is a value just barely outside the interval, and we do reject. Oh, yeah. Let me grab one of these and talk over it. So let's pick the one where we rejected. So we'll pick this one right here. Okay. So this graphic, let's talk over it. So with this right here, so these relate to your sign for the alternative. This is your does not equals, this is your greater than, and this is your less than. So the only confusing one I think a lot of times is the absolute value one. And the absolute value one is going to flip it on both sides. So when you have the absolute value right here, it's going to take it, and wherever you land, we landed at the negative. So you see this is our result. It's then going to mirror image it over to the other side. So it's going to take it and mirror image it. So the first one right here, this number right here is the addition of both of these areas. That number right there is the addition of both of those areas. Now, this number right here might be the confusing one to a lot of people. This number right here is going to be where you landed, but then you look, we need to shade to the right of it. So there's 97.52% shaded to the right of that. And then this value right here is to the left side of that. So that's the less than. And both of these right here add up to 1. These are both p-values for the less than or the greater than or less than test. The t-statistic right here is found via the equation y bar minus mu naught s over square root of n right there. And we see here the standard deviation. This is s. This is the degrees of freedom, which come from n minus 1. This is the actual estimate, which is going to be y bar. And this is mu naught. Does that make more sense what you have right here? Everything right here is all p-values. So these are all p-values. My horrible handwriting. Does this help out some more, Sam, right here? And these are the p-values are all the probabilities right there, and the t-statistic, like that comes from this t right here. This is a t with n minus 1 degrees of freedom. Does that make more sense of it? Hopefully. I think that's just the sloppy part. And we'll see if there's more questions, but this is how to look at this output here and what it's explaining. And these are the p-values right here. The one that's most noticeable when you look at p-values is the two-tailed is going to be this one and this one. That's the two-tailed. And then, oh no, don't be sorry. I'll read the question in 2 seconds. And then this is this one right here. That's the less than. And then the greater than is the shaded above this. That's the greater than. Let me see. Sorry, I think I'm a bit confused. So the values indicate the different alternatives, but what I can read from the value itself. Oh, which value are you talking about? This explain further. The values indicate the different. Yeah. Okay, yeah. You're talking about I see what you're saying. These right here tell you which alternative was used. So these indicate to you, color changing pen, tell you which alternative was used. So if somebody set up their test to look like the null hypothesis, let's not use that color today. If someone set up their test to be the null hypothesis is that the true mean hours UT students take is equal to, so the null would have to be 15.53 because that's our null. And then the alternative they used is the null hypothesis has that it's not equal to 15.53. Then they would use the following p-value right here. If they set it up so that they wrote their alternative that it's greater than, or let's do less than. If they set it up less than, then this would be their p-value right here. So whichever sign they used in their alternative then relates to the p-value they find. So that would be the p-value for the less than test. There's 3 different tests, and they're all related to this sign right here on the alternative. Is that making more sense, Sam? So whatever sign you use on the alternative will denote which way you shade it. So if we pick an alternative hypothesis, do we match with our type? Yep, exactly. So if you use the does not equals to, like whatever the sign is right in here, so we'll put kind of a thing right here. So whatever the sign is right here, whatever that sign is relates to that relative alternative you'll pick. So how's that looking right there, Sam? And then if you notice, you shade that way. I think I have a picture up. Hopefully the picture, I think it's going to be right about here. Where do we have the shading picture from today? Here we go. So the does not equals shades both sides, the greater than shades to the right, and the less than shades to the left. And what is the threshold for rejection? 0.05. Unless otherwise stated, 0.05. So when the p-value is low, than 0.05, reject the null. When the p-value is high, than 0.05, we do not reject the null. When the p-value is low, reject the null. When the p-value is high, just let it fly. And usually 0.05 is our assumed alpha. We wrote something about that today. You're welcome, Sam. Excellent having you here. Swing by any time. Just trying to work out the problems. And we put a bunch of equations up today. We did a bunch of work. Love it. I don't know where we put here's where we write out the nulls and alternatives. I think we got it. Man, 1 hour help session for the project. I think we're good. Woo, you can see a mini me right there. Oh, you know what? We earned it, everybody. We earned it. It's time. What times are these normalies? You're 207? Oh, cool. Oh, wait, are you doing the project in 207, Sam? Oh, man, I miss teaching 207. I used to, we'd have Soda Lab, back when we could actually see each other in person. We'd play Mario Kart, play Smash Bros. We are awesome. So anytime you see me live on YouTube, you can hop in, you can ask questions, and we can go over any material. I'll show you my office hours. Let me get that for you real quick. So you can swing by anytime, ask questions. I just need to go find them. If I am live on YouTube, I am here to help students be like, explain this concept. And I'll say, okay, I'll explain that concept. We'll end here with some fun videos. So we got here, these are my office hours, and you'll just see a live video on YouTube. So you can see Brian's YouTube office hours. Tomorrow I'll be on from 1 to 2, 1 to 3, 1 to 2. We're doing a switch up of the Kahoots, but you can play the Kahoots. You can come in to win the Kahoots. And there's more fun in store. There's more craziness. My email's bstevens@utk.edu. If anyone needs anything. Semester's almost over, I know. We're going to end here with a fan favorite today.
Tiny Brian is back. Tiny Brian's voice sounds all crazy. I don't know what happened to my voice. Okay, everybody.
Tiny Brian's voice got all crazy. I need to fix Tiny Brian's voice. Tiny Brian. What is going on with his voice?
I'm Tiny Brian. Okay, that's better. People can understand me now. Whoa, my voice has an echo. I'm fine with that. Okay, everybody. Let's do this. It's time to end class. Here's our last bit of advice. Here we go. Everything is fine. Don't worry. Here we go.